Hi everyone, welcome to the second lesson of mechanism drawing, identifying the source and the sink and knowing how to move our electrons, or rather we call them arrow pushing. Alright, so in the first lesson we talk about identifying nucleophiles and electrophiles, and in this lesson we are going to start moving electrons. So just a number of key points. Okay, the first key point is that electrons move from an electron source, right, to an electron sink. In most cases, electron sources are your bonds, all right, single bond, double bond, triple bond, all right. In our case of a double bond is our pi electrons. Okay, we can also have our lone pairs of electrons that can move, all right. And for electron sinks, most of the time we are interested in uh, moving our electrons to an atom. Okay, there are many other cases, but in general these are our the examples that we have, all right. So the second step is that the full arrow will represent the movement of two electrons. Alright, so if you only have a half arrow that looks like that, it just means one electron has moved. Alright, a full arrow represents the movement of two electrons. And lastly, it is important for you to take note of the charges. Alright, so let's take all three of these points and put them into our example here. Alright, so over here we have a SN2 mechanism of nucleophilic substitution mechanism. And so in the previous lesson we learned that there is a lone pair of electrons on our ammonia on NH3. Alright, so this is our nucleophile. We have an electrophile here, alright, because we have a delta plus carbon. Alright, because this chlorine is electronegative. Alright, so it gets a delta minus. And how would the electrons move? It will move from a source to a sink. Alright, so this is electron rich, so it's a source. The sink is our atom here. Alright, so this is our first source to sink. Alright, and then now I have to think about where the second arrow moves to. Alright, so now if we take a look at this carbon, alright, it is currently saturated. It already has 4 bonds. Alright, it has one bond to CH3, one to Cl, two to hydrogen. If it takes in another NH3, right, it will now have 5 bonds, which it cannot hold 5 bonds. So what will happen is that one of the bonds, sigma bonds, needs to break. And so um, in this case chlorine is the one that broke off. Alright, so once again we go source to sink. The source is your sigma bond here. Alright, this is your source, then chlorine atom is your sink. So what will happen is that the source will move to the sink. Alright, and what we will get at the end of the day is, right, we have our NH3, and then 1 hydrogen, 2 hydrogen, 1 CH3, and then we will get our Cl atom out. Alright, but of course this is not complete. Alright, I do not have a Cl atom out and my nitrogen has one missing charge. So let's take a look at the charges. Alright, so the chlorine atom here received the whole bond. So alright, so it received the electron. Alright, and one of the electron in this double bond used to belong to chlorine. Alright, sorry, in this single bond, one of the electron used to belong to chlorine, the other electron belonged to this carbon atom. Alright, so because it took away both of that electrons, so this chlorine gets a negative charge because it has one additional electron now. On the other hand, nitrogen was the one who gave electrons to this carbon atom. That is why it will have a positive charge now. Alright, so at the end of the day we have to check if our charges are balanced. So if you take a look here, there's a one positive charge, one negative charge, it is neutral. And then we look at our reactants, right? Our reactants have no charges at all, they are both neutral, so it is correct. Alright, so this is how we can do our arrow pushing and draw electrons from the source to the sink, and remember to take note of the charges. Alright, thank you.